what I want to do is to basically go through three different looks at fish capture, three different case histories. Firstly, it's looking at the shallow lakes in the Waikato, then next looking at Karori Reservoir and focused effort on perch that Dave West alluded to. And then lastly, it's probably a surprise to Tony, but you're on there because we're going to talk about your Gambusia trapping, which you did in removal from one of the campus ponds, which is a different species that isn't often focused on. So it all began really with John Hayes back in 1987. I think he did this work, published in 1989, when he looked at the comparative efficiency of minnow nets, Fyke nets, trap nets, gill nets, and a couple of different seining methods. This is a bit of a horrendogram. There's far too many figures on there, but the important thing to look at is the fact there were no carp in Lake Whangapai and Waihi. There were no carp caught in those lakes back then in 1987. So it's pre-carp invasion, but also the goldfish and catfish were somewhat effectively caught by gill nets and rudd. So there were a few rudd there then, and the only method that caught the rudd were the gill nets. So it sort of suggests it was the obvious thing. I'm sure you were aware of this when you planned the carp removal from the Pico lakes. So we chose Mangahia to do a pest fish removal. How hard can it be? You just set a few nets and take the electrofishing boat out. So this is a peat lake of 10 hectares. Now it turns out that 10 hectares is a bit of a challenge of the size of a lake. Say it fast, it doesn't sound very big. Maximum depth of about 1.6 metres, so pretty shallow. It's a hypertrophic peat lake, and so we use conventional methods of Fyke nets, boat electrofishing and gill nets. So the lake itself is here to the southwest of Hamilton, and is a candidate lake for ecological restoration because of this deep fringe of vegetation already around it. Access is quite tricky. So the preliminary work showed we had 4 introduced species, catfish, goldfish and rudd among them, and 3 native species, and longfin eels, sort of surprisingly, in this lake, which was an interesting find. Just see a close-up of the vegetation. The grey willows have been sprayed here at this point to remove those and to restore it back to native vegetation. So the fish removal we did in April 2010, but before we removed the fish, we did a mark and then so the removal included a recapture. So we marked about 3,000 fish and then ended up removing almost 6,000 fish. And so here we look at the catch from Fyke nets, gill nets, and boat electrofishing, and so it's a reasonably impressive set for Fyke nets of 231 net nights and 21 hours of boat electrofishing. It was a pretty hard effort over 7 days. So, and you can see a clear distinction of bias between the methods. So the catfish and the eels are basically vulnerable to the Fyke nets. They're benthic, and the leaders on the Fyke nets channel them in really well. The gill nets caught goldfish quite well. The effort on the gill nets wasn't actually huge in this lake, and didn't catch any eels, so quite low on catfish compared to John Hayes. But the boat electrofishing was the clear winner when it came to the goldfish. And although we didn't think there were any koi carp to start with, our preliminary fishing of nearly 3,000 fish didn't catch any koi carp. We got 23 out of the boat electrofishing. So when we looked at the capture efficiency of all methods, we could make population estimates. We knew what we caught, and we could look at the percentage that we actually removed. And so I've already talked about the bias of the methods, but basically we did a reasonable job on catfish, removing about 46%. Goldfish we did a terrible job on. There were huge numbers of small goldfish there, and after we'd finished our mark recapture estimates, there were 24,000 goldfish, an estimated biomass of nearly 3 tonnes in that lake. The pluses here show that the estimates are really just what we caught, so they're not actually modelled estimates, but we probably caught less than 1% of the rudd. So all methods here were pretty ineffective on rudd. Short fin eel, we caught 57%, and long fin eel we caught about 43%. So basically, of the marked initial proportion marked, we thought we wanted to get 20% of the initial population marked. We did that for catfish, we did that for short fin eel and long fin eel. In fact, way exceeded it for the eels, but we didn't do very well for the goldfish. So this doesn't matter too much except for the precision of that population estimate. Lake Ohinewai is the larger lake that Grant will talk about and Adam's already talked about. So a variety of methods we used in Lake Ohinewai, which is a 16-hectare lake. So rudd were low catches, catfish low catches, but Fykes were clearly the way to catch those. Goldfish, and Adam, you said the pen trap here, which is sort of like a giant Fyke net, but it has 2 wing leaders. And this was quite effective for goldfish, so we actually had a bait at the entrance to get the fish into it. So there's a part of the net here which is submerged, so the fish have to go in to get to the bait. And for koi carp, the baited trap and baited pen trap was by far the most effective method, with boat electrofishing shortly behind. So, and the x-axis here is in kilograms per day. So up to 40 kilograms per day caught by both boat electrofishing, nearly 60 kilograms a day from the pen trap carefully deployed.
Brennan,
yeah.
The difference between the bait trap and pen trap is that pen trap had a quarter hectare and locks on it with one-way doors going in.
Oh, right, okay.
So they had to get in and then get in the trap.
Right, okay, that's right. That was that deployment with the big sort of...
so these traps were 2 in the corner of a square box.
Right. No, I recall. Yeah, okay. So that can work, but that was a huge effort to set that up. That was that whole enclosure.
So then a week they started going underneath the enclosure, and they were so thick that you would walk across a bed of carp and catfish to get out to that launch. And they dug a hole about a half meter deep, so you would have to move the pin probably weekly for it to be effective, because they figured out how to feed the trap.
Sure, so a large amount of effort. So very effective, but comes at a cost. So boat electrofishing, we've run this since 2003. It's still a pretty useful tool. It's a very good tool to get koi carp. Vast numbers of koi carp are very easily caught with this. And this was 11 minutes fishing in Whangapē, as I recall. 87 kilos of fish. So basically, and this is recapping back to the Mangahia results, we got 675 kilos of invasive fish, which was 19% of our estimated 3.6 tonnes of total. That took about 30 person days of marking, and you wouldn't always mark before you removed, but it's quite a good idea because it tells you what your target is. And if we make a rough estimate of, say, $250 per person day, then we've got about $10,500 total for that removal. So that's just for the removal, not including the marking, which is about $94 a kilo for that particular exercise. And that was in Mangahia with the goldfish. Boat electrofishing, if we're actually targeting koi carp, we can get easily 500 kilos a day. It depends on how dense the carp are to start with. And with a 3-person crew, that gets the cost down to about $1.50 a kilo. But that's targeted for a single species in the right conditions of shallow littoral where the carp like to inhabit. Fyke nets were about 36 to 43% efficient for the catfish and the eels, but very inefficient for goldfish. So it's another story of one method not getting everything. Boat electrofishing was varied in efficiency, but it was about 4 to 15% efficient for the catfish and eels. So it gives you a view of the catfish and eel population. It's not a good removal technique for those species. About 12% efficient for the goldfish, and the big problem, as I say, with the goldfish was that there were so few, so they were so small and so numerous in the shallow margins. Gill nets were about 0 in some cases to 1.5% efficient, so they weren't terribly efficient in the context of Mangahia fishing. Karori Reservoir was the place we deployed the boat, as Dave's already mentioned, for perch. And the good thing about using the boat was it was very unselective for sizes. So this is a typical kind of shot of the size ranges from young of the year and 1+ fish right through to 2 and 3 year old fish. This is a typical shot of the young of the year, vast numbers in Karori Reservoir, unfortunately. We also tried mist netting and gill nets of various sizes. This is Nick holding up a good catch of age 1 perch from Karori Reservoir. And unfortunately, we introduced the night shift because we tried day and night and found that nighttime fishing was far more effective for perch. So these individual sites here, if we compare the numbers caught at one side of the day and then on the same side at night, they're 2 to 27 times the catch rate. In 2008, we got 31 times the catch rate at one individual site at night time. Basically, anything after about 7:30, just at dusk, when the sun's going down in summer, is good enough to start fishing, and the catch rate's much higher than it was during the day, because the fish tend to come up into the range of where they can be caught by the electrodes. Quite a big size bias between the electrofishing and the netting. So if we look at the length frequency of the perch here, boat electrofishing on the left and gill netting on the right. So we did put out a range of sizes here to try and overcome the size selectivity, but even then you can see that the number of age zeros is much higher, 608 of them with the boat electrofishing compared to only 81 with the best gill nets and finest mist nets that we could deploy. And so we got about 3.7 fish per minute, and a couple of thousand fish, and about 1.5 fish per metre of net. So can't be totally equivalent there, but we caught about slightly more electrofishing than we did netting that first year. So the lessons from Karori, we estimated that there were between 20,000 and 22,000 perch in this 2.3 hectare lake. In 2007, we removed about 4,000 of them. We went on in subsequent years to remove almost 11,000 in total. The steep sides meant that we couldn't deploy Fyke nets, so we estimated we removed about 18 to 20% of the total number of fish present, and about 8 to 10% of the total biomass. This was 24 person days, so we had a crew of 6 there for 4 days, which is about 164 fish per person day, about 3 kilos per person day. And if we cost it out again at about $6,000 just for the personnel cost, then we get about $500 per kilo. So these perch don't weigh much. They're pretty expensive fish. We got about 11 to 22% efficiency from our estimated population with the number of fish we took out, and the gill netting was probably half that in efficiency. And unfortunately, the night time in summer was the absolute best time to fish for perch. So going on to work that Tony did, I think this was your summer scholarship work, wasn't it, Tony? We looked at Chapel Lake on campus, and this is a very small lake, 0.44 hectare, and maximum depth of 1.8 metres. So what we tried here was minnow nets, and Tony set these around the edge of the lake, which is mostly shallow, but there's a few areas where it sort of drops off a bit, and the deepest part of the lake here is in the centre, so very high densities of Gambusia around the edge, and so these traps were set in roughly the same position over 6 days, basically trying to estimate the population by removal, because no one was going to mark these and trying to mark recapture on Gambusia. And what we found was that we got a pretty good reduction in numbers of Gambusia, and this is a catch rate of fish per trap, up to 40 fish per trap, and so declined reasonably well, except day 4 they sort of did a little resurgence. And so if we looked at the number of Gambusia and put those into a zip-in removal population estimate, and I should have said we use these collapsible nets, which are a lot cheaper than the G-minnow traps, and they work pretty well, quite effective, and can be baited. Bait traps here doesn't mean they were baited. These are unbaited, so we're pretty sure they were here. So we didn't bait these ones. They're just for catching bait, so they're called bait traps. And from these removal estimates, we suggest that the estimated population was about 7.4 thousand Gambusia. So that took about 12 person days, which is about 428 fish per person days. Of course, these are absolutely tiny. Because they're so small, it was about 11 kilograms of fish, and so that's about 259 a kilo. But nevertheless, we did get a reasonably effective reduction. The bad news is that we had at least a couple of thousand left, so we would have, to get the fish out by trapping, it would have been, well, practically the catch rates would go down so low that it would be pretty much impossible to eradicate by trapping, but we did make a significant reduction in the numbers. So in summary then, the catch rates are highly variable depending on the water depth and the morphology of the littoral habitat, and the methods need to be highly targeted to the different species, and we recommend, if the budget's there, to do a preliminary survey to at least get an idea of the population size, so you know the target biomass. And the personnel costs of capture can vary from $100 to $500 a kilo, with the exception of the boat electrofishing, which if you're targeting an individual species like carp can be quite a bit lower cost. And the problem for lakes like Mangahia and even Ohinewai is the conventional methods of fish capture were beyond our budget to remove 80% of the original biomass, which was our target to look at a threshold for recovery of the ecosystem.